In this video, we're going to be doing example 3, and there are 3 different indefinite integrals for us to evaluate, 3 different finding the general antiderivative questions. We're going to break them up into 3 separate videos. So I'm just going to do this one in this video. All right, so evaluate this indefinite integral. This integration symbol, that swoop ds symbol, together with that dx provokes in me a question. What's the question? The derivative of what function? Is the one that they're showing us right here. Of what function is x cubed plus 6x squared minus 1 over x? And in fact, it's not just what function, it's what family, right? We want to do a plus c. So when I look at the green function, I want to see how it's put together. I see that it is put together with terms, with addition and subtraction. X cubed plus a 6x squared minus a 1 over x. I can compartmentalize my thinking and go ahead and just say, well, the derivative of what function is x cubed plus the derivative of what function is 6x squared minus the derivative of what function is 1 over x. I can compartmentalize my thinking. I can just anti-differentiate x cubed, then 6x squared, then 1 over x. And then what do? I'm going to add and subtract those antiderivatives respectively. All right, power rule, one of our favorites. Doing power rule in reverse, what are you doing? You are adding 1 to this exponent. 3 plus 1 is 4. And you are dividing by that new exponent. You can either write it like this. Division by 4 is times a fourth. They're both real good. How about I do this time? Plus I see a constant multiple times a function of x. Just like the derivative of a constant times a function is just the constant times the derivative of the function. Going backwards, i.e. doing an antiderivative, i.e. doing an indefinite integral, that constant multiple is coming along for the ride. So we have 6 times. Now the derivative of what function is x squared? We're going to do power rule in reverse. You're going to add 1 to this exponent, x to the 2 plus 1, which is 3, and divide by that new exponent. Then, minus the derivative of what function is 1 over x? Well, the derivative of the natural log of x is 1 over x. But remember, in example 1, it turned out actually that the derivative of the ln of the absolute value of x is 1 over x. If that part explanation was a little hard for you, that's totally okay. I want you to get practice seeing that and knowing that you need to do 1 over x and just get some repetition, and then maybe go back and read our explanation for why this is true. What have I forgotten? My plus c. Right? Here is my answer, and we can go, oh, let's actually simplify. 6 divided by 3 is a 3. But this is my answer, and we can always check by differentiating. X to the 4th over 4 plus 6 divided by 3 is 2x cubed minus ln, not just x, but ln absolute value of x plus c. We are done. And let's go ahead and check by differentiating. Right? So the big question, the derivative of yellow plus c, will it be green? All right, so let's see. The derivative of my answer, x to the 4th over 4 plus 2x cubed minus ln, not of just x, but the absolute value of x, plus any constant, plus 1, plus e, plus pi squared, plus any constant. When I take this derivative, do I get the green function? When I take the derivative of my antiderivative, do I get this original function? All right. Terms, yay, I can compartmentalize my thinking. The derivative of x to the 4th divided by 4 is 4 times x cubed over 4, plus the derivative of 2x cubed is 2 times 3x squared, minus the derivative of ln x is 1 over x. Moreover, the derivative of ln absolute value of x is 1 over x. And the derivative of a constant is 0. Simplifying here, we've got 4/4, which is 1 times x cubed, so we've got x cubed, plus 2 times 3 is 6 times x squared, minus 1 over x, and lo and behold, the derivative of yellow plus c was in fact green. Check. We did great. All right. So this concludes this video. In the next video, we will be doing this example.